Hi, welcome to this lesson on Euclidean geometry, polygons. Let's have a look at question 3. We're given that RS is a diameter of the circle with center O, and chord ST in this diagram is produced to W outside the circle. Then the chord SP, when produced outwards, meets this tangent WR at the point V. We're also given that angle R1 is 50 degrees. So the first question is to work out angle WRS. Okay, so immediately what comes to my mind is that this is a tangent. So RW must be perpendicular to OR. And that is because tangents are always perpendicular to radius lines. Okay, so therefore this entire angle here, R1 plus R2, that must be 90 degrees. Okay, but now we know that angle R1 is given as 50 degrees. Okay, so I can subtract 50 degrees from both sides and get that angle R2 must be 90 minus 50 degrees, which is 40 degrees. Okay, so this angle here is 40 degrees. Okay, so the angle WRS in total, okay, so we've gone a step ahead, but the angle WRS is the entire angle R1 plus R2. So that would be the solution for this one here, 90 degrees. Okay, but we did additionally work out another value because of that. Next, I want us to work out the size of angle W, which is over here. Now again, let's put in the information we've already worked out. This was 50 degrees, therefore that was 40 degrees. Okay, so I noticed something, that there's a large right angle triangle here, WRS. And this is 90 degrees. Okay, so if I can work out this angle, then this will be 90 degrees minus that angle. Okay, because of complementary angles in a right angle triangle. So let's see if I can work out what this angle S is going to be. Well, first of all, I know that angle T1, this angle here, that must be 90 degrees. And the reason for that is angles in a semicircle, because we have the diameter RS subtending to the point T on the circumference. So therefore that is a 90 degree angle. So now we have another 90 degree angle triangle. We have this here, TRS, and we know that this angle R here is 40 degrees. So therefore this angle S here must be 50 degrees. So this entire angle is 50 degrees. Okay, so therefore 90 minus 50 is 40 degrees. So this angle here must be 40 degrees. So let's put all that logic into writing now. So I can say in triangle RTS, angle S must equal 90 degrees minus 40 degrees, which is equal to 50 degrees. That is by angles in a triangle. Okay, and therefore from that now, I can say in the larger triangle, triangle WRS, which is also a right angle triangle, angle W must be 90 degrees minus this angle S. But that angle S we worked out is 50 degrees. So 90 degrees minus 50 degrees is 40 degrees. Okay, so therefore we have that to be 140 degrees. Next, they want us to calculate the size of angle P1. So now let's look carefully. Where's P1? It's this angle here. Now immediately my eye gets drawn to the chord ST, because first of all they mentioned it, and they said that chord ST, you can see it subtends to the point P on the circumference, and it subtends to the point R on the circumference. Okay, so now angle R2, which we worked out, because this was 50 degrees, that must have been 40 degrees. So therefore I can say that angle P1 must equal angle R2, and your reasoning there is angles in same, angles subtended by same chord. Okay, so angles subtended by same chord, and you can reference the chord, in this case it is chord ST. Okay, we also worked out angle R2 equals 40 degrees previously. Okay, so that was over here. So therefore angle P1 must also equal to 40 degrees. Okay, so this angle here is 40 degrees as well, angle P1. Lastly, they want us to show that angle V1, which is this angle here, is equal to angle PTS, which is this angle, this entire angle here. Okay, so there's a few ways we could go about this, but instantly what's popping out in my mind is that this shape here, WV to P to T back to W, that is a quadrilateral. And interestingly enough, we want to show that this angle V1 here is equal to this angle outside here, which, as you can see, if you can extend out the line, that is an exterior angle. And if you go into the interior opposite angle, that's exactly what we want to show. But where does that sound familiar, showing that an interior angle or an exterior angle is equal to an interior opposite? That is true if and only if the shape is a cyclic quadrilateral. So if we can prove that WVPT is a cyclic quadrilateral, then automatically this result is true. So that's my goal. I'm going to show that WVPT is a cyclic quad. Okay, so here's my proof. So I know that these angle V1 and angle T3, or angle V1 and angle PTS, those are the ones I want to show are equal. So it's more than likely means that I'm not going to use them in my proof. I'm going to use the other angles. So the other angles I'm referencing in my proof here is I'm going to look at angle W and look at angle P2. If I can show that these angles are supplementary, that means they add up to 180 degrees. If I can show that, then this is a cyclic quadrilateral. Okay, so notice, so we've shown that angle W is equal to 40 degrees already. Okay. And angle P1 we worked out to be equal to 40 degrees as well. So actually you could even use this argument here, that this exterior angle is equal to this interior opposite angle. So we can even use that. So I can say, therefore, angle W equals angle P1. Therefore, WVPT is a cyclic quad. And again, my reasoning for that is that the exterior angle, which is P1, is equal to the interior opposite angle, which is W. Okay, so again, let me just visualize that shape for you here. So you've got it. Here's W, V, P, and T. We extended this line out here, and this is the exterior angle, which was 40 degrees. That was P1, which we showed in the previous problem. So if I go into the interior and then opposite it, that angle W was also 40 degrees when we worked it out in the first question. Okay, so because those are equal to each other, that is a cyclic quad. So therefore, because it's a cyclic quad, we must also have that angle V1, which is this angle here, is equal to the exterior angle outside opposite it, which is angle PTS. Okay, and again, the reasoning is exterior angle equal to interior opposite angle because WVPT is cyclic. Okay, and that would end your proof there. Okay, so there's a multitude of ways we can go about writing it. As long as your argument is logically sound and your line by line can be met with the diagram, then you will get your full marks for that as well. All right, so again, this is how we would do this type of question. I'll see you in the next one.